Okay, so now there are two things in here that we need to learn, and that is basically resistors in parallel and resistors in series. So if you're not familiar with parallel and series, so parallel and series, so what that is, basically if you connect two resistors to, first of all, the schematic for a resistor is basically something like this. So this would be a resistor. In a circuit you would show a resistor, you would draw a resistor like this, and it's called the schematic of a resistor. For example, the schematic of a diode would be something like this. This is the schematic of a diode, and so on. There are other things like, for example, capacitors and transistors and so on and so forth. Now if you have basically two resistors connected in this manner, these are two resistors connected. These are two resistors connected in series. Okay, for example, this is R1 and, for example, R2. R1 and R2 connected in series. And you can have resistors connected in parallel as well. For example, the same two resistors, if you connect them this way, then they are basically, for example, R1 and R2 here. Then R1 and R2 are connected in parallel. This is called parallel, this is called series. Now we do this, we connect resistors in parallel and series of course for a purpose, because when you connect, for example, two resistors in series, what happens is that, let's say that, for example, you have a resistor over here. For example, you have this resistor R1, this is a 10 ohm resistor. R2, this is a 5 ohm resistor. Then the total resistance in this, related to these two resistors, if I call it R of T, R of total, would be the value of R1 plus the value of R2. So R of T would be equal to 10 plus 5, which is equal to 15 ohm. That is basically why you connect resistors in series, for example. And this total resistance in this case is also called the equivalent. Is also called the equivalent series resistance. Series resistance. This is the kind of term that you might come across, and this is basically then denoted by, for example, sometimes R of EQ, something like that, R of equivalent. Now there is, as we mentioned before, it's also possible to connect resistors in parallel. So for example, if you connect a resistor over here with another resistor in parallel, then, for example, if this is R1, for example, 2 ohm, and this is R2, 2 ohm. Now the equivalent parallel resistance of these two resistors is going to be basically 1 over R of T is going to be 1 over R of t is equal to 1 over R1 plus 1 over R2. This is the equation that you use in order to find the equivalent resistance of these two resistors. So 1 over R of t is equal to basically 1 over 2 plus 1 over 2, which is equal to 1 ohm basically. Now of course this is 1 over R of t. This is 1 over R of t is equal to 1 ohm. So if you take the reciprocal of this, the reciprocal of this would be R of t, and the reciprocal of 1 is 1, so R of t is equal to 1 ohm. So as you can see, when you have two resistors, basically two ohm resistors connected in parallel, the equivalent resistance is going to be 1 ohm. Now suppose that you have two 8 ohm resistors, for example, connected in parallel. Suppose that you have two 8 ohm resistors connected in parallel. This is R1 and this is R2. This is 8 ohm and this is also 8 ohm. So 1 over R of t again is equal to 1 over R1 plus 1 over R2, which is equal to 1 over 8 plus 1 over 8, which is equal to basically 2/8, which is equal to 1/4, which is equal to 1/4. So 1 over R of t is equal to 1/4. That means that R of t is equal to 4 ohm. So as you can see, when you have two 8 ohm resistors connected in parallel, the equivalent resistance is 4 ohm. 8 ohm, 4 ohm. And over here 2 ohm, 2 ohm, and 1 ohm over here. So that means that when you connect these resistors, the resistors, if they happen to have the same, if they happen to be the exact same resistors having the same amount of resistance or value for resistance, then the equivalent parallel resistor would be half of any of those two resistors. And of course this equation you can write it as for example 1 over R of t. You can write it as basically 1 over R1 plus 1 over R2. So this side you can write it R1 R2 as the LCM, and then basically you get R2 plus R1. So 1 over R of t is basically this. So that means that they take the reciprocal of both sides of this equation and get R of t is equal to R1 R2 over R1 plus R2 over R1 plus R2. So this is for two resistors. And if you have, for example, if you have more than two resistors, then that gets a little bit more complicated. Meaning that, for example, if you have 3 resistors over here connected in parallel, three resistors here connected in parallel, R1, R2, and R3, then the equivalent parallel resistance, or 1 over R of t, is going to be equal to 1 over R1 plus 1 over R2 plus 1 over R3. Now again over here we can find the LCM as, so this is 1 over R of t is equal to R1, R2, R3, and then here you get R2 plus R2 times R3, sorry. Here you get R2 times R3 plus R1 times R3 plus R1 times R1 times R2. And if I take the reciprocal of both sides of this equation, I'll get R of t is equal to R1 R2 R3 over basically R1 R2 R2 R3 R3 R1. You can write it this way: R1 R2 plus R2 R3 plus R2 R3 plus R3 R1. And the way that you can memorize this thing is usually more than 3 is you usually don't need it, so you don't need to derive any formulas for that. So the way that you can memorize this, of course, is R of t is equal to R1, so you write R1 R2 and R3 in the numerator, and then if you think of these resistors as a cycle, you have R1 and R2 and R3 over here and R3 over here. So you need to start from R1, and so you have R1 R2 R1 R2 plus R2 R3 R2 R3, and then R3 R1 going to the beginning, over here, and over here. So R3 R1. That's basically the equation that you can use. And now let's do a couple of exercises to understand this a little bit. Work with the formulas. For example, let's say that you have an R1 which is equal to 1 ohm, and you have an R2 which is equal to, for example, 1 ohm. And then these are the total or equivalent resistance. And these resistors have been connected in parallel. So since the resistors have been connected in parallel, so we said that basically R of t is equal to basically R1 R2 over now I did forget the formula actually. Well, actually you don't need to really memorize anything. You know that 1 over R of t is equal to basically 1 over R1 plus 1 over R2. Of course, in this case, you know that since these resistors are connected in parallel and they have the same value, the equivalent parallel resistance is going to be 1/2 ohm basically, but we can calculate it. So then this is equal to 1 over 1 plus 1 over 1, which is equal to basically this is the same thing as 2. This is 1 and 1, so this is equal to 2. So 1 over R of t is equal to 2. So that means that R of t is equal to 1 by 2, or 1/2 ohm basically. That is basically your equivalent resistance. Otherwise, if you want to use the other formula so that you don't have to take the reciprocal of these sides, let's basically derive it again. So 1 over R of t is 1 over R1 plus 1 over R2, and so 1 over R of t is equal to R1 R2 R1 plus R2. So that means that then if I take the reciprocal of both sides, R of t is equal to R1 R2 over R1 plus R2. So now if I use this formula, if R1 is equal to 1 ohm and R2 is equal to 1 ohm, again connected in parallel, and this is of course for a parallel circuit, R of t is going to be equal to 1 times 1 over 1 plus 1, which is equal to 1 over 2 ohm, and that is basically your equivalent resistance. Or if, for example, if your R1 is equal to, for example, 1000 ohms, and your R2 is equal to 500 ohms, then R of t is equal to R1 R2 over R1 plus R2. Now in this case, you see these numbers are a little bit too large, meaning that if I write this as, for example, R1 R2 would be 1000 times, for example, 500 would be a large number, many zeros, and then you have 1000 plus 500, and you would get basically 5 zeros over 1500, and cancel these two out, and then you would have to divide 5000 by 15, which is something like 5000 divided by 15, you will get 1000 thirds or 333.3, for example, ohms or so. Or you can say 333 ohms, approximately 333 ohms. Now, to get over this problem of getting too many zeros and these large numbers, what you can do is that you can write your R1 as 1000 ohms, which is equal to 1 kilo ohm. And R2, you can write it as 500 ohm, which is equal to 0.5 kilo ohm. Now, but the thing is, when you want to add these two together and multiply them together, both have to be either in kilo ohm or both have to be in ohm. You cannot mix, for example, you cannot mix ohm with kilo ohm. They are two different things. You cannot add them together that way. But if both are in kilo ohm, then of course you can add them with no problems. And of course, when you do that, then your R of t, you will get that in kilo ohm, not in ohm anymore. Meaning that now in this case, your R of t is going to be equal to R1 R2, R1 plus R2. And that's equal to, for example, R1 R2 is basically 1 times, for example, 0.5 over 1 plus 0.5. And as you can see, this is 0.5 over 1.5. Multiply by 10, you'll get 5 over 15, which is equal to 1/3. So this is 1/3 kilo ohm in kilo ohm. So 1/3 kilo ohm is the same thing as 1,000 thirds ohm, which is again the same thing that we calculated, approximately 333 ohm basically. So if your numbers, I mean, if it's easier, I mean, in particular situations, it's easier to convert your numbers so that you don't have to do unnecessarily too much calculation. And now suppose that, for example, you have your R1 as 3600 ohm, and you have your R2 as, for example, 1800 ohm. Again, here your numbers are way too large, so I write this as 3.6 kilo ohm, and I write this as 1.8 kilo ohm. And so then R of T is going to be equal to R1 R2 over R1 plus R2. And then I can write this as, for example, basically 3.6 times 1.8, 3.6 times 1.8, 3.6 plus 1.8, and that is 36 times 18 is equal to 48, 4, 24, 28, 0, and 36. You have 8 over here, 14, 1, 6. You have 2 decimal places, 6.48. 6.48 over 3.6 plus 1.8, 14, 1, 5.4. 5.4. So you get basically, you can write this as, for example, 648 divided by 540, and then you can simplify it somehow. You can simplify it somehow. Of course, in these cases, you do need to use a calculator. 648, 540. 648 divided by 540 is equal to, for example, 6/5 or 1.2. Is equal to 6/5 or 1.2 kilo ohm, which is equal to 1200 ohm. Now, of course, there is a sentence over here. It says that R of T, basically in a parallel circuit, R of T is always smaller than the smallest of the resistors in parallel. R of T is always smaller than the smallest of the resistors in parallel. So that is that. So that's all about resistors. There is not much more to talk about resistors. In the next video we will talk about power, and we have a couple more things: the graph of resistance, the voltage divider, and so on and so forth. Okay, so in the next video we will talk about power, and let's see where that takes us. I'll see you in the next video.